Right, today let us start our next chapter, which is motion in two dimensions. Previous chapter was motion in a straight line. We studied how when bodies move in straight line in one direction or in one dimension, how to study their motion we saw in the previous chapter. Now this is an extension of it, motion in two dimensions or motion in a plane. Motion in a plane. And we will study two particular types of motion in this motion in a plane. First one is projectile motion. Second is circular motion. First is projectile motion. Second type of motion is circular motion. These are two examples of motion in a plane. Okay, right. Let us take projectile motion first. Projectile motion. These three situations that you see here, we see everyone might have seen this in real life, daily life. So if you are throwing a basketball into the ring, the path followed by the ball will be like this. Or if this biker is doing a stunt, he is going like this in this path. And if you throw a javelin or a shot put, or if you kick a football, its path will be like this. Okay, like this. So all these bodies, the paths or the nature of these motions that these bodies are following, we call them as projectiles. Projectile. Projectile. So if you take any object, projected at an angle other than 90° with horizontal, and moving only under the influence of gravity is called a projectile. So this is the definition of projectile. Any object which is projected. Projected means thrown, giving some initial velocity at an angle other than 90° with horizontal. Other than 90° with horizontal means if this is the horizontal, this is the horizontal, and if you throw an object at an angle 90° with horizontal, 90° with horizontal means vertical. This is 90°. Then what will be the path of this body? It goes straight up, stops, comes straight down. That is motion in one dimension. We have already studied this. We have already studied. Body goes straight up, comes straight down. But if you throw the same body at an angle other than 90°, let us say I'm throwing it making 30°, 60°, 45°, some angle with horizontal other than 90°. Let us say some theta. Then the path followed by this body will be like this. It will not go straight up and come straight down. It follows a path like this, like a basketball, like this biker doing stunt, or the javelin, or the shot put, or the football that you kick, or a arrow which is which is released, or a bullet which is fired from the gun. All these things, they follow paths like this. Also, we can treat all these things as projectiles. All these things as projectiles. And one more condition, the body, that projectile must be moving only under the influence of gravity. Only gravity. Other than gravity, no force, no other force must be acting on it. Okay, that means suppose if a aeroplane is flying, aeroplane starts from here, runs on the runway, takes off, flies a certain distance, and again lands on the runway somewhere here. Can we treat this like a projectile? No, this is not a projectile because aeroplane flies due to the thrust developed by its own engine. Other than gravity, the thrust due to its engine will be acting on it. So external force, another force is acting. So aeroplane is not a projectile. Helicopter is not a projectile. A missile which is fired is not a projectile. A rocket is not a projectile. They have their own, they have thrusts or forces
Mechanical
acting on them.
energy, sir.
They have thrusts or forces acting on them due to their engines. So we cannot treat those things as projectiles. Only bodies moving under gravity are projectiles. Okay. Then these projectiles are of two types. We will study two types of projectiles. One is oblique projectile. Second is horizontal projectile. Oblique and horizontal. What is the difference? Oblique projectile is like this. If you throw a body, let us say you're throwing a javelin or shot put or a football, you're kicking a football, it goes like this, lands here. Okay. This is a point of projection and this is a point of striking. This is point of projection from where you are throwing that object. And this is the point of striking, where it strikes or where it lands. That is the point of striking. And these 2 points, they lie in the same plane. Point of projection and point of striking are lying in the same plane. Or on the other hand, suppose this is a tower, a building, something, and from top of the tower, you are throwing a ball or a stone, something horizontal. Its path will be like this. It will fall somewhere here. So in this situation, the point of projection is here. And the point of striking is here. The point of projection and point of striking are not in the same plane. Here, point of projection and point of striking lie in same plane. But
Sir,
point
here
of
same plane
projection,
means only one surface, which is a horizontal, sir.
point of projection and point of striking, they lie in different planes. Point of projection is in this plane. Point of striking is in this plane. They are different. We call such a projectile as horizontal projectile. And this horizontal projectile can also be like this. We can throw a body like this, upward from the tower. Its path will be something like this. This is also a horizontal projectile. Okay, let us study first in detail about oblique projectile. Oblique projectile. Yes, first one. And see, one important point to understand this projectile motion is you should be able to handle, or you should be able to see horizontal and vertical directions separately in order to understand projectile motion. If you could do this one thing, projectile motion will be very easy for you. If you mix up both horizontal and vertical directions, it will become complicated. So simple technique to understand projectile motion easily is separate horizontal motion and separate vertical motion. When we are discussing in horizontal direction, you must look only in horizontal direction. When we are discussing in vertical direction, you must look only in vertical direction. If you can do this thing, it will be very easy. Okay. Now here, let us say, let us take the path of the projectile. Path of projectile or equation
Sir, once can you scroll up?
of trajectory. Equation of trajectory for a projectile. Okay, what is this? See, first of all, x and y axis, and now I am projecting a body. Let us say I'm throwing a ball from the origin with some initial velocity u, which is making some angle theta with horizontal. I'm throwing a body with initial velocity u, and this u is neither along horizontal nor along vertical. It is inclined. It is making some angle theta with horizontal. So if I throw this, its path will be like this. Its path will be like this. Okay. There you say you are playing cricket, you are at the boundary, you get the ball and you are throwing that ball to the wicket keeper. So the ball will follow a path like this, which is a projectile. Okay, now we should understand in detail clearly, very, very clearly, how or why does that ball or the projectile follow this path? What is the reason? To understand it,
Gravity, sir.
to understand this, the first point is this ball or this body is traveling in two dimensions, along horizontal and along vertical. In the previous chapter, we studied these two directions separately. A car was going on a road, a train was going, a man was running, acceleration, distance travel, time taken, all these things. Then we studied motion under gravity. A ball is thrown vertically upward, or a ball is dropped from a certain height. Water drops are falling from certain height. Velocity of striking, time taken, all these things. We studied them separately. Now here, these two motions are taking place simultaneously in projectile. This ball is traveling along x direction, that means horizontally. At the same time, it is traveling along y direction also, that is vertically. So this is a combination. This is a combination of horizontal and vertical motions. Okay. To understand these two motions, we will understand them. So we will consider them separately, then add up. Then you will get the result. Okay. At the time of projection, the point of projection, I am giving velocity u. So I can resolve this velocity into horizontal and vertical components. This is horizontal component of velocity. This is vertical component of velocity. And if you have not forgotten vectors, I can write this horizontal component as u cos theta and vertical component as b u sin theta. The side or the component which is attached to the angle will be cos, other one will be sin. So u cos theta is the velocity of the projectile along horizontal direction. That means it will cover its journey along horizontal direction depending on this velocity, u cos theta. And u sin theta is its velocity along vertical direction. So its vertical motion will be decided by based on this u sin theta. Okay. Now, first of all, let us try to understand What happens to u cos theta with time? What happens to u cos theta with time or along horizontal direction? So first try to understand the path or the motion of this projectile along horizontal direction. Okay, what is the velocity along horizontal direction? Initial velocity. Initial velocity. How much u cos theta? Okay. This u cos theta, it is along horizontal. Now this u cos theta, while the projectile is traveling, it travels for certain time in the air. So with time, does this u cos theta change or remains constant?
Change, sir.
U cos theta changes or remains constant?
Changes, sir.
Yes, sir.
Who is responsible for changing u cos theta?
So gravity.
What is the direction in which gravity acts?
Downwards, sir. Downwards, sir.
This. What is the direction of this u cos theta? This.
Right. Horizontal, sir.
Can gravity, which is means this acceleration, can this acceleration which is acting downward change velocity which is acting horizontal?
No, sir. Sir, once can you
So
repeat what you said?
the u cos theta will be constant only, sir. It is,
Velocity is horizontal, u cos theta, gravity is vertical, g. Will this acceleration due to gravity acting downward change u cos theta? No.
No, sir.
U cos theta will not change due to acceleration due to gravity, because acceleration due to gravity does not act along horizontal direction. G always acts vertically downward. G does not act like this. If
Sir,
G
friction.
acted, we are ignoring air friction here. If G acted along horizontal direction, then what should have happened is, if you drop a ball from a certain height, this ball along with falling down, it should have gone like this also, if G acted in horizontal direction. But there is no G along horizontal direction. G is only along vertical direction. So there is no acceleration along horizontal direction. That is the point. There is no acceleration along horizontal direction on the projectile. Acceleration along horizontal is zero, since G does not act along horizontal. Okay. So it means now see, remember we are discussing horizontal motion. Look in horizontal direction only. Don't go up or down. Just go left or right. So no acceleration along horizontal direction. If acceleration is zero, velocity will be.
Constant, sir.
If acceleration is zero, velocity will be constant. Therefore, u cos theta will be constant. U cos theta will be constant until the body strikes the ground. Throughout its journey, throughout its entire journey, u cos theta will remain constant. It will not change. Whatever you are giving it at the time of projection, that value will remain same. Let us say u cos theta is some 10 meter per second, and u sin theta is also some 10 meter per second. Then this 10 meter per second will remain constant, same throughout the journey. Here, at this point, 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 and at this point. U cos theta will remain same. So I can show it like this. At this point, when the projectile is at this point in its journey, its horizontal velocity is u cos theta, same. At this point, horizontal velocity u cos theta, same. Magnitude is same, direction is same. Magnitude is same, direction is same. That's why I'm drawing arrows of same length in same direction. Okay, at any instant of time or at any position, if you want horizontal velocity, how much will it be? U cos theta. Okay, so the motion of the entire thing from this point is the motion of projectile along horizontal direction is uniform. Okay, motion of projectile.
Sir,
Yes.
so when it is uniform, should be a straight line that by but why is it that curve?
We have studied only half of it. The remaining half is there.
Okay, sir.
Motion of projectile along horizontal is uniform motion. Uniform motion because it is not velocity is constant. It's uniform motion along horizontal direction. Okay, right, fine. Now let us study this in vertical direction. Along vertical direction. Right. What is happening in vertical direction? What is the initial velocity in vertical direction? U sine theta. U sine theta is the initial velocity in vertical direction. U sine theta. Now, will this U sine theta remain constant, or changes with time? Will U sine theta, which is along vertical direction, remain constant, or changes with respect to time?
Changes, sir.
Because
Because
of
G is acting.
acceleration due to gravity. U sine theta is vertical. Acceleration due to gravity is acting down. So obviously this will be affected by acceleration due to gravity. U sine theta is like, now you take this vertical motion of the projectile as you are throwing a body vertically upward, straight upward with velocity u sine theta. What happens to it? This u sine theta goes on decreasing with time. Decreases, becomes zero. There the velocity becomes zero. It stops for an instant, then starts to come down. This increases, becomes maximum. So if you do this thing along vertical direction, u sine theta decreases with time first. At the time of projection, let us say it is some 10 meter per second. Then after a certain time when the body is here, it will become some 8 meter per second. Then 6 meter per second, 5 meter per second, 4 meter per second. Then finally it becomes zero. When vertical velocity becomes zero, now the projectile will be at this point, which is its peak or maximum height. Here vertical velocity is zero. It has only horizontal velocity. Vertical velocity u sine theta becomes zero, just like a ball which is thrown vertically upward. Then what happens? It starts to come down, so its velocity increases. So at this point, it reverses its direction and its value starts to increase in the opposite direction. Here further increases. Here further increases. Okay. Now, if you remember parallelogram law, consider this point of the projectile. This is the velocity along horizontal, this is the velocity along vertical. Will the resultant of these two be something like this? That's what parallelogram law says, resultant of two vectors. And at this point, this is horizontal velocity, this is vertical velocity. The resultant of these two will be something like this. And at this point, there is only horizontal velocity. So resultant velocity will be in horizontal. At this point, this is horizontal velocity, this is vertical velocity. The resultant of these two will be something like this. At this point, resultant is this. Like that, the path will be decided by the resultant velocity. Resultant velocity, and that's why it is this curve, or it's actually we call that shape as parabola, parabolic shape. Path of a projectile is parabolic in nature. Okay. Now let us try to study how this vertical velocity changes with time. How vertical velocity changes with time. Which equation can we apply to study vertical motion of the projectile? Which equation can we apply? I can apply h is equal to ut minus half gt square. H is equal to ut minus half gt square. Okay. Or I'll take y because it is we are taking it along y x and y axis. I'll take y. Or before that I'll write here u sine theta decreases with time becomes 0 and increases with time. From time of projection decreases until maximum height is reached, then increases in the opposite direction until it strikes the ground. Okay. So that means motion of projectile along vertical direction is accelerated motion. Motion of projectile along horizontal direction is uniform motion, non-accelerated motion. But motion of projectile along vertical direction is accelerated motion due to g. Okay. I will remove this and write one point here. See, before just one more addition to horizontal direction, motion in horizontal direction. Let us say the projectile has covered some, let it is here. If it is here, its horizontal displacement is this, right? X. And its vertical displacement is this, Y. X and Y are the horizontal and vertical displacements. Okay. Now, can we write the horizontal displacement of projectile in time t is x is equal to u cos theta into t. Displacement is velocity into time. Displacement is velocity into time. That means time is x by u cos theta. Say this is equation 1. Okay. Now I will write the same thing for vertical motion. The vertical displacement of projectile in time t is h equal to ut minus half gt square. H is here y. U, which u? Or okay, I will write it like this. H is equal to ut minus half or plus basic equation. Take basic equation ut plus half gt square. Now, what is h? H is here y, vertical displacement. U, initial velocity. Which initial velocity? Projectile has two initial velocities, horizontal and vertical. We are discussing vertical here. So here we should take uy, initial velocity along y direction. T plus half gt square, plus or minus minus, because velocity is upward, acceleration due to gravity is downward. So g will be negative. Minus half g t square. This is equation 2. Now you substitute 1 into equation 1 into. What do you, in place of uy here, I'll calculate u sin theta. U sin theta. So substituting 1 into y is equal to u sin theta into t. T is x by u cos theta minus half g t square. T square is x square by u square cos square theta. Okay. Any cancellations here? U will get cancelled. So we have y is equal to sin theta by cos theta.
Time.
Theta x minus g by 2u square cos square theta into x square. G by 2u square cos square theta into x square. This is a very important equation, relation, which we call as equation of trajectory. Trajectory means path followed by the body. Path followed by the body. That equation, that path followed by the projectile, which is this path, it is mathematically given by this equation. We have equations for different shapes. For straight line, there is an equation. For circle, there is an equation. For the ellipse, there is an equation. For parabola, there is an equation. This is equation of a parabola. If we compare this with I will make some small substitutions. Put tan theta is equal to A and G by 2u square cos square theta is equal to B. Then you get y is equal to ax minus bx square. Ax minus bx square. This is the equation of a parabola. Parabola, which is a shape of this kind.
Sir, here y means the maximum height, sir, or the height of the point.
Displacement at some time t. Vertical displacement at some time t.
Okay, sir. X is the point, sir. Point of displacement.
X is horizontal direction displacement.
Okay.
Equation of a parabola. Okay. So just how we represent y equal to mx plus c, which is the equation for a straight line. This y equal to ax minus bx square represents a parabola. Therefore, path of a projectile is a parabola. Path of a projectile is a parabola. That shape, it is not semicircle. Something that it is semicircle. No, it is not semicircle. It is a parabolic shape. This is a parabolic shape. So any object which is thrown like this, like a projectile, will follow a parabolic path. Its equation is given by y equal to tan theta x minus g by 2u square cos square theta into x square. X is displacement along horizontal direction. Y is displacement along vertical direction. U is the initial velocity of projection. Theta is angle of projection. This is the first basic thing. From this, you should understand how to analyze the motion of projectile along horizontal and vertical directions separately. Then, when you mix these two things, how you get the resultant path. Then, Along horizontal direction, motion of the projectile is uniform. Along vertical direction, it is non-uniform. These things. Next, going further. Time of flight. Time of flight, capital T. We denote this with capital T. What is this time of flight? As the name itself says, it is the total time spent by the projectile in air. Total time for which the projectile is in air. It is the total time for which the projectile is in air. Okay. How can we find out this time of flight? Simple. See, I'm taking a projectile motion. I'm projecting a body with initial velocity u, making angle theta with horizontal. It will be going like this, reaches maximum height, then falls down, hits here. This is the point of projection. This is the point of strike. Okay. To understand its motion, I can resolve its velocity into two components. This is u cos theta. This is u sin theta. Okay. Now, see, I can write for entire journey of the projectile. For entire journey of projectile. If I write h is equal to ut plus half gt square, if I apply this equation for entire journey of the projectile, okay, then what is h? Vertical displacement. How much is this vertical displacement for entire journey? How much is vertical displacement for entire journey? You are throwing it at this point and it is striking at this point. How much is the vertical displacement? Is 0. If you are not able to answer this, if you are not able to understand it, that means you are doing the mistake that I warned you not to do. You are looking in both directions simultaneously. If you look in both directions simultaneously, you will go something like this and you will get lost. What does h mean here in this equation? Displacement. Which direction? Vertical direction. H is displacement in vertical direction. How much is it? 0 or not? Not able to understand.
Yes, sir. The maximum height is 0 because it reaches 0 and then increases.
So the initial and final points both are same, sir.
Maximum height is different. This is maximum height reached by the projectile from ground during its journey. That is a different thing.
So in displacement, sir, the initial and final points both are same, so that's why.
For entire journey, it is starting at this point and landing at this point. How much is it displaced along vertical direction? 0. It is at the same level. If I ask you how much is it displaced along horizontal direction, your answer will be this, from here to here. But we are not speaking of horizontal direction now. We are speaking of vertical direction. So displacement of the projectile along vertical direction is 0, which is equal to u. What is u? Velocity along vertical direction. How much is it? U sin theta.
So u sin theta
Into t. plus or minus half. G is G. In vertical direction, G is G into T square. So if I send this to other side, I get U sine theta into T is equal to half GT square. And 1T will be cancelled. So you get U sine theta is
Sir,
equal
it
to
will be minus half GT square.
half GT. U sine theta is equal to half GT. From this, T is
Sir, 2u sin theta by g.
2U sine theta by G. And for total journey, we call this time as time of flight. Capital T is equal to 2U sine theta by G. Capital T is 2U sine theta by G. Okay. And you can break it down further. From here to here, from the point of projection to point of striking, it is taking some time 2U sine theta. How much time will it take to go from point of projection to maximum height? Half of it. So from this, we can write time of ascent TA as U sine theta by G and time of descent TD U sine theta by G. If I add up these two, you will get 2U sine theta by G, which is total time of flight. So point is to be understood, from point of projection to reach maximum height, this point, it will take time of ascent U sine theta by G. From maximum height to point of striking, it will take time of descent, which is U sine theta by G. And the sum of these two things will give you the time of flight 2U sine theta by G. This is time of flight 2U sine theta by G, very important basic things. Right, so we have studied two things. One is equation of the projectile, other is time of flight of the projectile. Two more things are there: maximum height reached by the projectile and horizontal range. How to what maximum height will the projectile go depending on your U and theta, and to what the maximum distance will the projectile go depending on U and theta. We have to derive these relations. We'll do that tomorrow. Okay, so see you tomorrow and good night.
Thank you.
Thank you, sir. Bye, sir.
Bye, sir. Thank you, sir. Good night, sir.
Good night, sir.